Climate change is a challenge of managing risks. Risks for people and infrastructure. Risks for ecosystems. Risks for freshwater resources and food production. Steps to build resilient societies can reduce these risks. Adapting to climate change can benefit communities, economies, and the environment.
Good morning, ladies and gentlemen. Welcome to this press conference to present the IPCC Working Group 2 report, the report on impacts, adaptation and vulnerability, which is Working Group 2's contribution to the 5th assessment report, which has just been released. So today on the podium, we have the chair of the IPCC, Dr. Rajendra Pachauri, in the middle there. On my left, Michel Jarraud, the Secretary General of the World Meteorological Organization, one of the sponsoring bodies of the IPCC. On his left, Renata Christ, the Secretary of the IPCC. On Dr. Pachauri's left, we have Chris Field, one of the co-chairs of Working Group 2, who will be presenting the report to you in a minute. And on his left, Maggie Apondo, who is one of the coordinating lead authors of that report, and Habiba Gite, who is one of the review editors of that report. And we should have Vicente Barros, but he's been unavoidably detained. We hope he'll join us later. I also have to apologize that we don't have Spanish interpretation this morning as we'd been hoping. So I'm going to hand over now to Dr. Pachauri to say a few opening words. Dr. Pachauri, the floor's yours.
Thank you very much, Jonathan, and good morning to you, ladies and gentlemen. We're absolutely delighted at having completed this extremely important report. And as you know, this has involved 309 authors directly and thousands, if you were to count those who were expert reviewers and also those who were contributing authors. We have assessed 12,000 different publications, and I can also inform you that a very large number of them present new knowledge and new material. Why should the world pay attention to this report? Well, we have assessed impacts as they are happening, and impacts on natural and human systems on all continents and oceans. And I would like to emphasize that in view of these impacts and those that we have projected for the future, nobody on this planet is going to be untouched by the impacts of climate change. We know that all the glaciers are shrinking due to climate change, and that has major implications for runoff and water resources downstream. And this severity, of course, varies from location to location. There are some parts of the world where these so-called water towers, which are in the form of ice which stores substantial quantities of water, would be getting depleted in future if we don't do anything about climate change. And that certainly will affect the availability of water for a large number of people, hundreds of millions of people downstream. We also see migration of species because with climate change, several species that have existed in harmony with natural conditions for thousands of years would now and are actually finding it difficult to live in the same locations, and therefore there is a migration of these, and we have assessed the rate at which different sets of these living species would move from one location to another that's more favorable as a result of the impacts of climate change. There are negative impacts on crop yields, particularly in the lower latitudes. And this has serious implications for food security, for livelihoods. And may I emphasize the fact that this really would be a severe challenge for some of the poorest communities and poorest regions in the world. There are serious health impacts, which include heat-related mortality deaths, mortality and vector-borne diseases increasing. There are extreme events which have serious implications for the safety of lives and property. And we have looked at adaptation experience quite extensively and what's happening and what has been happening in different parts of the world. The one thing that we have come up with is the importance of adaptation and mitigation choices, because this is the only way that we might be able to reduce the risks of climate change. There are several key risks, particularly in areas like low-lying coastal areas, the small island states which are very vulnerable to sea level rise. There would be possible breakdown of infrastructure networks, key services like electricity supply and all. And if I could give you an example, not necessarily related to the impacts of climate change, you can see what has happened with several extreme events in different parts of the world in recent months and years. So the reason why I think the world has to take this report seriously is because there are implications for security of food supply, the impacts of extreme events on morbidity and mortality. There could also be severe, pervasive and irreversible impacts on species. And there is a risk of crossing tipping points as a result of increasing temperatures, which of course is very difficult to project or predict, but that's a risk that we have to keep in mind in devising strategies for the future. The last 2 points I'd like to make are the importance of these impacts to human security, because climate change can lead to displacement, can lead to increased conflicts, and there are already several stressors that are leading to conflict in different parts of the world. The impacts of climate change could very well exacerbate some of those risks. There are implications for territorial integrity. And finally, I think the ability of human society to embark on a move on climate resilient pathways depends to a large extent on the extent to which we are prepared to mitigate the emissions of greenhouse gases. And as you know, in a couple of weeks, we are going to be completing the Working Group 3 report, which deals with mitigation. And on the eve of that, I want to emphasize that what happens in terms of impacts of climate change in different parts of the world would be determined to a large extent on the extent to which we are prepared and are able to mitigate the emissions of greenhouse gases. So please be also prepared to look at the findings of the report of Working Group 3. And then finally, at the end of October, we'll be bringing out the synthesis report, which combines and synthesizes the knowledge from all the 3 working group reports of the 5th assessment cycle. Thank you very much.
Thank you very much, Pachi, and welcome to Dr. Barros, who's just arrived. Could I ask Michel Jarreau of the WMO to say a few words now?
Thank you. Thank you very much. And I would like to complement what Dr. Pachauri just said. This Working Group 2 report is an element of a much bigger jigsaw. The first element of this jigsaw, you remember, was Working Group 1. And Working Group 1, there were 2 important messages. Climate is changing. There is no doubt any longer. And 95% confidence it is due to human activities. Well, there are many other important messages, but these were some very critical messages. Now, this report is dealing with impact, vulnerability, and adaptation. In a sense, it's new in the structure of IPCC to combine this, but I think it's a very good way to address it, because these elements have to be looked at very much in connection with each other. The third element will be what Dr. Pachauri mentioned, the mitigation report in Berlin. So one thing one has to really appreciate is that this is based on a huge scientific work. Actually, if you think about it, this is the biggest scientific assessment in the whole history of scientific disciplines ever. So many scientists have participated to that, and I want to thank them for their contribution. This is really the most solid evidence you can get in any scientific disciplines. There's a huge increase in the amount of information available, which was assessed by this. Although we recognize that even more has to be done to get more studies, more assessments from developing countries. So when we say it's the most solid, it doesn't mean that this is the end of the road. Every time we try to do, and IPCC tries to do better and to provide more solid information. So I hope you realize that now we are at the point where we have so much information, so much evidence, we can no longer plead ignorance. 30 years ago, the previous generation maybe was damaging our atmosphere, the Earth, out of ignorance. Now ignorance is no longer a good excuse. We know. Therefore, we have the information to make decisions and to act upon this information. There may be still a few question marks. This should not be excused not to act. The next 2 years will be absolutely critical. There's a number of major milestones. Let me mention a few. This year, in September, 23rd of September, the Secretary General of the UN, Ban Ki-moon, will convene a climate summit in New York with lots of heads of states, heads of government, very high-level participation. The 3 working group report of the IPCC will be very important element to inform this summit. And there will be also the continuing information to the UNFCCC, the Framework Convention on Climate Change process, with the COP20 this year in Peru, and next year the one where decision will have to be made in Paris in 2015. But there are other meetings where climate change will be a sort of fundamental element of the discussion. The meeting of the small island developing state in September this year. Next year in Japan, the World Conference on Disaster Reduction in Sendai. And the whole discussion about sustainable development. We know we cannot talk about sustainable development if we don't address the climate change issue. So this report indeed provides a lot of evidence on the impacts, on the vulnerability, on sharing experience, on what has been done in adaptation. But adaptation will require information, and that's why the whole United system together, but also many other partners outside of the UN system, have got together to develop what we call a global framework for climate services. What is it? It is to provide decision makers from the head of government to the farmers with the information they need to act upon the finding of this report. So all these things are part of a big ensemble. Let me stop here because otherwise I would talk for too long and we need to leave time for questions. Thank you.
Thank you very much indeed, Michel. Could I ask Maggie Opondo, who's coordinating lead author of the chapter on livelihoods and poverty, to say a few words now? Thank you.
Yeah, thank you very much, Jonathan. I'd just like to share my experiences with you as a coordinating lead author for Chapter 13, Livelihoods and Poverty. It has really been a rewarding experience. It gave me a genuine opportunity to serve the scientific community and the world at large. The journey has been long, tiresome, but rewarding. The journey apparently started here in Japan, in Tsukuba, where we, in Working Group 2, had our first lead authors meeting. We kept getting comments from reviewers. For example, in Chapter 13, for our first order draft, we had over 500 comments from 41 reviewers. The second order draft had about 300 comments. I think the IPCC process is giving scientists an opportunity to come out of their ivory towers and begin to do work that is rewarding to the world. Often as scientists, our work does not influence policy, but this is a genuine opportunity to give the world, share our knowledge with the world so that we can make the world a better place. The most exciting part for me has been the last few days. They were gruesome, long nights, but we realized as scientists that we must give clear messages from our studies and our assessments so that they can be used to make the world a better place. I think the IPCC is unique in that we work with the policymakers who okay the outline of the working group reports. Therefore, I think this is the way to go if the scientific community is to contribute to making the world a better place. Thank you.
Thank you very much indeed, Maggie. I'd now like to ask Dr. Gite, one of the review editors on the Adaptation, Opportunities and Constraints chapter, to say a few words. Thank you.
Good morning, and thank you for the introduction. I'm one of the 66 review editors for this assessment report. The review editors, as for the authors, come from all over the world. I myself am from Australia. The IPCC chapters actually go through extensive reviews. As a scientist, I find that the IPCC chapters are reviewed more than any paper I published in my life. These reviews are done by experts as well as by governments. For the chapter that I represent, we received about 1,000 reviews from all over the world, and they really were about improving the content both in literature but also on issues that the authors needed to consider. In total, the assessment as a whole received about 50,000 comments. So as you can see, the authors have a huge challenge to address them and to consider each one of them individually. And as review editors, our responsibility is to make sure and guide the authors in addressing those comments. It is a challenge, but at the end of the day, it really did improve both the content and the literature that is covered within the chapters. And I think it contributed to the discussion over the last week. As Maggie said, it has been a grueling and long week, but overall it has actually improved the quality of the chapters and the assessment report. Thank you.
Thank you very much, Habiba. And to finish off this first part of the press conference, I'd like to ask Chris Fields to present the report itself. Thank you.
Thank you, Jonathan, and thanks all of you for joining us this morning and giving us a chance to share some of the findings of the assessment that, as you've already heard, hundreds of scientists around the world have carried out with great diligence over the last almost 5 years. The report I'm about to present really is a product of the entire scientific community. As Dr. Pachauri said, we had over 300 authors, but hundreds of other scientists from around the world contributed specific review comments building on scientific literature produced by thousands of their colleagues. In many ways, I see the IPCC report that we're presenting today as the top of a gigantic pyramid of scientific knowledge that's been developed around the world over many decades. If I could have the slides, please. It's a real privilege to share some of the key findings of the report. One of the things that's most central to the conceptualization of the challenge is what's the nature of impacts from climate change? What's the nature of the risk that leads to impacts? And when you think about impacts of climate change, you need to recognize that they emerge from risk, and risk is generated by the overlap of climatic events interacting with societal conditions, vulnerability, who's susceptible to harm and why, and exposure, what are the assets in harm's way. You can really understand risk of climate impacts as emerging from the interaction of these processes driven by climatic change, but also by socioeconomic processes, with the opportunity for decreasing climate change coming from mitigating emissions, as shown in the bottom part of this figure. With this conceptualization, it's clear that as a society, as a world, we have many approaches to reducing risk of climate change impacts. One is working through the side of reducing the amount of climate change that occurs, but the other is working through the side of improving society to decrease vulnerability and tamp down the overall risk level. When you look at the key findings of the report, as Dr. Giroux and Dr. Pachauri have already said, one of the most important findings is that we're not in an era where climate change is some kind of a future hypothetical. We live in a world where impacts of climate changes that have already occurred are widespread and consequential. We see impacts from the equators to the poles and from the coast to the mountains. There's no question that we live in a world that's already altered by climate change. One of the most high impact findings of this report is a map of where climate changes have occurred, where climate change impacts have occurred, what sectors have been affected, how confident are we in those changes, and what are the consequences of those changes. Here's a picture of the map, and I know it has too much detail for me to describe here, but you could think of this map as a portal, an entry point into a rich discussion of impacts that have already occurred. Impacts that have occurred in the Americas, impacts that have occurred in the Southern Hemisphere, impacts in Asia, Europe, and Africa. Around the world, everywhere you look, there are impacts of climate changes that have already occurred, already been documented, and already had consequences. Here's an example. This is in the oceans, a new topic for Working Group 2 to address, but where there have been profound impacts, and looking across a large range of ocean organisms. It's a study pulling together data over 359 different species, and it's a map of the distances that species have moved as a consequence of the ocean warming that's already occurred. And you can see the distances on the left-hand scale are in kilometers per decade, ranging up to over 400 kilometers per decade of movements toward cooler habitats that species have undergone as a consequences of the changes in their environment. Here's another example of changes that have already occurred, and this is the impact of climate change on large area food production, showing yields of wheat, soy, rice, and maize, with the average yield changes in recent decades as a consequence of climate change impacts, shown as percent per decade. And you can see that for wheat and maize, there have already been significant decreases in the rate at which ag yields are able to increase. Climate change has been an anchor holding back progress in increasing ag yields. And though we haven't seen similar changes in rice and soy, we know from future projections that all crops are at risk of future warming. But in the case of observed impacts to date, we're already seeing them profoundly and to a large extent in two of the world's most important food crops, wheat and maize. A striking feature of the report, as Dr. Pachauri has already emphasized, is that there are vulnerable people, societies, and ecosystems around the world. Much of the vulnerability is concentrated among the world's poor, but it's not only there. We see vulnerable ecosystems, people, and societies in the developed world as well. Wealth is not protection from vulnerability, but what you see is exposure and vulnerability unfold in different ways in different societies. The report has a lot of bad news in it, and it shows grave risks, but it also shows that people, societies, and governments are beginning to take steps to tackle those risks. Some of the steps are at the community scale. This is an image of local people planting mangroves to provide coastal protection in Tuvalu. Other kinds of adaptation that are already occurring are much more centered in technology and utilization of advanced engineering. This is a flood barrier in the Netherlands. It's another example of strategies that are already ongoing in order to provide protection, and much of the report is about how we're learning from the steps that are already being taken and how we can use this learning in order to raise ambitions for more successful and more comprehensive adaptation in the future. If there's a central theme to this Working Group 2 report, it's really that climate change is a challenge in managing risks. We know plenty about the climate changes that have already occurred and about the climate changes that are projected to make smart decisions, but we need to start making those decisions in the framework of managing risks, not in the framework of knowing, oh, I expect a particular impact at a particular point in a particular time. We need to be thinking about reducing risks and building more resilient societies. Because one of the key findings in the assessment of future risks is that the more it warms, the greater those risks are. Increasing warming, increasing magnitudes of warming increase the likelihood of severe and pervasive risks around the world, around the world's ecosystems, and across the world's communities. When you think about how to deal with those risks, we know a lot. And what we need to do is transform the realization of the risks into a platform for action. This is a conceptual diagram of the decision-making process that decision makers around the world are already beginning to use in order to comprehensively confront the challenge to build on the information that's provided in the IPCC and similar assessments. Because there's no question that risks of climate change increase with continued high emissions. The challenge is how to deal with that through a comprehensive package that involves finding a smart mix of ways to decrease emissions, as will be explored in the Working Group 3 report, and adaptation, finding the best, most effective, most useful ways to cope with the climate changes that can't be avoided. Here's an example of a way to think about managing risks. The figure on the left-hand side shows historical temperatures and possible future temperatures through the 21st century for a world with continued high emissions, the pink banner, and a world with ambitious investments in mitigation, the blue banner. This is a figure from the Working Group 1 report. But it's positioned here next to a comprehensive analysis of reasons for concern that emerge from the Working Group 2 report. You can think of these reasons for concern as a distillation of all the impact elements, all the risk elements, and all the vulnerabilities into a focus on the kinds of things people care about for the future. What are the risks to global aggregate issues, things like total biodiversity, total economic activity? What are the risks to unique and threatened systems, the one-offs here, the unique species, the unique natural environment? What are the risks of extreme events and catastrophes, or what are the risks of large-scale singular events like the collapse of a continental ice sheet? And one of the things that's really important in the Working Group 2 analysis is a framework for thinking about these big picture issues, these reasons for concern, individually, and not needing to composite them all into a single metric of global risk, recognizing that different stakeholders in different places really do value things differently. And what we've tried to do was provide a framework from which diverse values can be reflected intelligently and comprehensively to empower smart decisions by stakeholders with a wide range of different interests. And it's important to do that because the projections for the future really are grave. Here's an example of projections of future crop yields through the 21st century, and what the pairs of bars for each set of years show the studies projecting increased crop yields and the studies projecting decreased crop yields. Through the century, you can see that the studies projecting increased crop yields, the blue bars, get to be lower and lower and lower, and the studies projecting decreased crop yields, the brown bars, get to be taller and taller and darker, so that by the end of the century, something like a quarter of the studies are projecting decreased crop yields of greater than 50%. That's the dark brown bar at the bottom of the rightmost bar. The risks to global food security are really profound and a really strong motivation, along with many others in the report, for making smart decisions to ensure that we have a world that can cope effectively with these problems. And that's really the bottom line from the whole report. The report talks a lot about challenges, and it has its share of scary scenarios and doom and gloom, but it also talks in a very optimistic tones, well, in neutral IPCC tones that are rich with optimism about the kinds of steps that are already being taken to deal as effectively as possible with the climate changes that can't be avoided, and the opportunities for integrating ambitious efforts to decrease climate change, to deal as effectively as we can with the climate changes that can't be avoided, into a comprehensive view of a society that's advancing and taking advantage of steps to integrate climate change mitigation, climate change adaptation, and sustainable development into a vision of a better world, a richer that's more secure, more robust, and more vibrant. Thanks very much.
Thank you very much, Chris. Well, now we have just under an hour left for questions from you. We'll also be taking questions in from outside for people who have been following this press conference on the webcast. So please indicate if you want to raise a question, and if you're asked, please state your name and your media outlet. Seth, please. So there are microphones in the room, so please wait for them to be brought to you. Just coming.
Thank you. Seth Borenstein from the Associated Press. I guess maybe for Dr. Barros, who hasn't had a chance to talk, or Dr. Pachauri, I would like you to compare what you're seeing as the observed results now to 7 years ago, the last time Working Group 2 issued a report, and the AR3, however many years ago, more than about a decade and a half. Are the observed results about what you expected, less, more, and what does it mean? Because it looks like they are far more than you had predicted. And what does this tell us about your forecasts, and what does it tell us about the future? Are you overly optimistic and keep being shown things are worse than you think they'll be?
Well, as I said, there's substantially more knowledge and literature that's been taken into account in this report than was possible in the fourth assessment report. As an example, let me mention the projections that you've just seen presented by Dr. Chris Field on changes in agricultural yields. Now, when we did the fourth assessment report, we didn't have quite as much material available on these projections. But what you see today is profound. You know, we're living in a world where population is increasing very rapidly. And who knows at what level it will stabilize, 9 billion, 10 billion. And at the same time, we're facing the specter of reduced yields in some of the key crops that feed humanity. So, you know, this is just an example of the kind of new knowledge and new evidence that we're able to provide. And this is also true of, you know, what you find, for instance, with respect to species. And as Dr. Chris Field mentioned, we have gone into considerable depth on marine systems in this report. And this was really not possible. As a matter of fact, I remember very clearly in Valencia when we approved of the synthesis report in the last cycle, there was inclusion of the reality of ocean acidification, but we didn't quite have the knowledge that was available to us in looking at the implications of ocean acidification. We have much more of that today. And we tend to forget that when you talk about food security, it's not just what grows on land. A large part of humanity also uses nutritional material from the seas, from the oceans. If that's going to be affected, as Dr. Chris Field showed you, the result of migration from one location to the other has serious implications for food security in different parts of the world. So, I mean, these are just some examples of what we find with much greater certainty, with far greater detail today than was possible 7 years ago. And that's why I said that there is a reason for the world not really neglecting the findings of this report, because they are profound. And let me repeat once again, we have said very categorically in this report the implications for human security. We have reasons to believe that if the world doesn't do anything about mitigating the emissions of greenhouse gases, and the extent of climate change continues to increase, then the very social stability of human systems could be at stake.
Michelle, would you like to say something?
Yes.
Maybe
Let me complement
Sorry.
the answer of Dr. Pachauri. In this summary for policymakers, which was approved yesterday, there is more than 120 examples of impacts of climate change, with impacts that can be attributed to climate change all over the 6 continents. Thank you.
Yeah, maybe I could complement your question from 2 perspectives, because one of the part of your question was about the evolution from assessment 3, 4, 5, and Dr. Pachauri gave a lot of things on how much more detail you have. But let me concentrate on 2 things. One is sea level rise, because if we compare, sea level rise is actually occurring on the high side of what we were anticipating in the 3rd and the 4th assessment report. And it's not uniform. And we saw already some of the dramatic impact of that in the recent typhoon Haiyan in the Philippines, where, by the way, the sea level has been rising even faster than the global average by about 1.2 centimeters per year near where the cyclone happened. The other thing where there's significant better understanding on the vulnerability as well is on the fact, and this is in the report, there are many examples on the attribution. You see in the third assessment report, the typical answer scientists would give you if you say, is it due to climate change? The typical answer was, no, we cannot say that. However, what we see is consistent with what we expect, which is a correct answer, by the way. But now, on a few occasions, we have gone one step further. Some events can indeed, we can say, they would have been very unlikely, or in some cases impossible to occur without climate change. And although it's a little bit outside of the scope of the second working group report, because it's very recent, the recent heat wave and drought in Australia falls into this category. Thank you.
Thank you. Habiba?
Thank you. I was the coordinating lead author for the third assessment report on the ecosystem services when we started this evolution that was referred to by others. And we really were showing some observed changes in natural systems, I would say. If you look at it in the fifth assessment report, there are two different aspects. One is that you have some of the socioeconomic sectors being picked up, health, food systems, and livelihoods. But also now it's attributable to the changing climate. So that's actually a huge jump from the third assessment report. Thank you.
Gentleman there in the second row.
Thank you, moderator. My name is Satoru Mizuguchi of Housing Tribune of Japan. As Chris explained, there are some optimistic tone in the new report. The reason it seems to me that you raised at least three new concepts. One is solution space as a core concept, and the second is the focus on risk and iterative risk management, and the third is the integration of adaptation, mitigation, and sustainable development. Would you give us a concrete example of these three concepts applied in the community levels or municipality levels, especially at the coastal areas? Thanks.
Thank you for the question. And let me just say this sense of optimism is, I think, best characterized as guarded optimism. It's not to say that the risks aren't serious, but it's to say that we have a deep pool of options, we have a deep pool of experience, and I think a deep pool of creativity and innovation that could be applied to comprehensive and effective solutions. This idea that there is a solution space is really important. If climate change is totally unmanageable, what are we going to do? What I think we've been asked to do in the IPCC is analyze from a scientific perspective, what are the things that can be done? What's the map of the space of possible solutions? And what you see in the report is a big emphasis on how adaptation, vulnerability reduction, building resilience can be key parts of this opportunity space. And I think that the adaptation examples, even the two that I showed in the slideshow, are really good examples of unpacking the opportunity space. There are examples all the way from community level investments, protecting coastal habitats, improving coordination and communication among different parts of the community, up to very high level technology solutions with satellite monitoring for severe weather and improved technology for coastal protection, communication, transportation. The second question was about iterative risk management, and how can iterative risk management be key to making smart decisions about coping with climate change. One of the things we're seeing is that commitments to adaptation are really beginning to occur beyond the reacting to the past disaster, and people are beginning to think about how to build resilience so that future disasters aren't as bad or don't occur. And I think about iterative risk management essentially as being learning by doing, developing an adaptation plan, deploying it, seeing where it works, where it doesn't, improving that plan and deploying it again. Around the world, we're seeing a real flowering of investments in adaptation planning, building experience, and learning from that experience. And then the third real area is how adaptation and mitigation can work together. And I think in the past there has been a mischaracterization of the climate problem such that investments in adaptation or investments in mitigation should be understood primarily as pulling resources away from the things we hoped economies did, that they were a dead weight on the economy. And when you look at what's known about consequences of investments in adaptation and mitigation, you see exactly the opposite, that those can be investments that really strengthen economies and can be integrated into thinking about sustainable development, not only in poor countries, but in rich countries as well, in ways that can be components of ambitious plans for, as Maggie characterized it very eloquently, a better world.
Yes, if I could just add to what Dr. Christfield has said. The reasons for guarded or cautious optimism also lie in the fact that around the world today there is much greater awareness on climate change issues than was the case, say, 10 years ago. And I think given the fact that in the ultimate analysis, governments have to respond to the priorities and preferences of the people, if there is a growing awareness on some of the scientific realities of climate change, then clearly with all the options that, let's say, have been brought out in this report, we would find translation of those options into action. And I'd also like to mention that what is being revealed through reports like this are the enormous co-benefits of action. You see, if you take adaptation, for instance, let's say you put in place mechanisms, institutions, methodologies for dealing with, let's say, climate-related disasters. Those very institutions that you create can also be extremely helpful in dealing with non-climate related disasters. So you don't have to duplicate them. I would count that as a major co-benefit. And in the case of mitigation, which I'm sure we'll discuss in 2 weeks from now, there are a huge number of co-benefits. And therefore, I would say that all of this will become apparent, and I trust human society would give us justification for the optimism that Dr. Christfield has articulated.
Thank you, Patchy. I'd like to take a question from outside the room now. This is from Peter Spotts of the Christian Science Monitor in the United States, and it would be for Chris. Can you explain the reason behind the difference between the way Working Group 1 and Working Group 2 view attribution of observed changes, observed anthropogenic change? Why select the regardless of cause approach if Working Group 1 has a high degree of confidence in the human contribution to climate change?
So that's a really good question. There's a difference in the techniques, but it's really grounded in a difference in the goals. The Working Group 1 approach to attributing climate change to the human component is that we're really trying to understand the physics, and we're trying to understand in the picture that the climate system is presenting to us, what's the role of humans. When we talk about dealing with the future, what we really want to know is what's the sensitivity of things we value to climate change, food security, biodiversity, resilient economies. And the reason that we focus on understanding the role of climate change in these impacts is because that's what people care about. The goal, I think, of having this balanced approach where Working Group 2 tries to understand the response of the systems, of the human, physical, natural, biological system to climate change, is that when that builds on the understanding of the role of humans in the climate change that has occurred and is occurring, that lets you have a comprehensive package. If we tried to do both steps of the attribution problem in Working Group 2, we couldn't have that seamless handoff, and it would be very difficult to not have a disjunction the way I think about it is that you want to know the role of humans in the climate system, you want to know the role of climate in the impacts, and together those give you the comprehensive picture of the role of humans in altering the future.
Thank you, Chris. Do we have another question from the room, please? Suzanne.
Hi, thank you all for being here. I wanted to focus in on one of the points or sort of two twin points of the report, and that is this sort of inequality of impacts, and how these are impacts that are going to hit poor people in poor countries, are going to hit the poor and disadvantaged and discriminated here. And the combination of that with food shortages, how can you be a little more specific about what you expect to see in terms of human conflicts and things down the road?
Yeah, thank you very much for that question. What we're seeing from our Chapter 13, Livelihoods and Poverty, is that poverty is going to intensify the impacts of climate change, meaning that climate change acts as a multiple stressor. What do I mean by this? You find that in livelihoods, for example, people are already marginalized. If you take Africa, for example, the face of poverty often means multiple deprivation. It is the face of lack of education, hunger, lack of basic services, and coupled with this, we found out that in the urban areas, the poor are going to be harder hit. Africa has lots of slums, and within these slum areas, they do not have the proper facilities. Then you add on the impact of climate change or extreme events, and people become more vulnerable, sinking deeper into poverty and unable to come out of the poverty traps.
That I thought was an excellent answer, but let me just add one more factor. You see, a large part of the developing world lives in rural areas, and they are connected in some way or the other with agriculture. Now, with growing scarcity of water, for instance, and decreasing yields with agricultural crops, you would find a number of farmers who are largely dependent on rain-fed agriculture and produce just about enough food to take care of their own needs will be severely disadvantaged. So I think that certainly will lead to conflict, because where would these people go? You would have climate refugees, and this would be multiplied even further by those in low-lying coastal areas and in the small island states. Because if they are threatened in their very existence, there would clearly be a large number of environmental or climate refugees. And therefore, all of this has the potential for exacerbation of those factors that are leading to conflict even today.
Thank you. Could we have another question from the room, please? Gentleman at the end of the second row, please.
Hi, I'm Kiyoshi Ando from Nikkei newspaper. I understand that you have more data and materials to show that the impact is even more serious than when you published the last report. But in terms of financial means and investment needed for adaptation and risk management, I don't see as much quantitative description in the report as one would expect. But I think that is much needed for future negotiations. Are you trying to kind of prevent yourself from going in too much into such issues, or is it just a matter of difficulty?
So in the IPCC, our mandate is to provide a comprehensive assessment of what's known and what's not known in the scientific literature on the key issues that we address. There's no question that being able to come up with comprehensive, useful analyses of the requirements for effective adaptation, including financial requirements, really important. But what we found when we looked through the available studies is that there really isn't enough information for numbers to be useful. There are a few studies out there that present numbers for the costs of adaptation But we feel really strongly that our job isn't to pluck a unsubstantiated number from the scientific literature, but really provide a careful assessment of what's the information that's really evaluated, that stood the test of time, and as enough resolution to be useful in the policy process. What we concluded in this report is that the specific numbers which are presented and analyzed in detail in the background chapters really haven't reached the level of resolution that they contribute in a meaningful way to discussions about policy. We have a great need for those and a great need for improving the numbers in the future, but what we need to recognize is there are serious challenges for adaptation, serious requirements for financial commitments, but there's an equally serious need to continue to do the evaluations to figure out what those financial requirements are.
Thank you. Another question from the room, please. Any more questions from within the room?
I should just say the report must be perfect if no one has any questions about it.
Oh yes, at the back, John, please.
Thank you, John Parker of The Economist. Let me just ask a follow-up question to that one on the costs of adaptation. I know you just said that all the numbers are fairly bogus anyway, but most of them are of the order of 1 or 2% of GDP. And your estimate for the global cost of the impacts of climate change are, page 20, between 0.2 and 2% of GDP. So in other words, on your own showing, we're spending about the same amount on adaptation to prevent costs at sort of 1 for 1. Is your report showing that we don't really get any net benefits from spending money on adaptation?
That's a great question. And what we would like to be able to say in a really comprehensive way, what are the damages that accrue from unmitigated climate change if we just do continued high emissions? What are the damages that accrue if we mitigate ambitiously? What are the residual damages? And the difference between those you might think of as the avoided damages. And you could think about those avoided damages in a number of different ways. The reason I showed the reasons for concern is that it characterizes some of the ways you might think about it. Global aggregate impacts is one. Risk to rare and endangered systems is another. Unique singular events is another. These distributional effects that we talked about are others. And so the idea of the global aggregate number is not irrelevant, but it's certainly not the only way you want to think about it. But the important key to the numbers is that the number we present for the global aggregate economic impact is more or less the sort of linear, deterministic approach to the impacts that might hit the economy at a warming of around 2 degrees, kind of the warming level you might get with ambitious mitigation. That's the residual impacts, and those are the ones we have to adapt to anyhow. The number that you would like to have, what would be the impact of the global economy at warming level without mitigation, with continued high emissions, we don't present because we think that it's sort of beyond the capability of the linear traditional economic approaches to describe that. And so therefore the way we present the issue of avoided impacts, the difference between the unmitigated and the residual, is in terms of reducing the risks, especially to these 5 key reasons for concern, of which the global aggregate damage is an important one, but it's not necessarily the most important. The distribution of impacts, the threats to rare and endangered systems, the risks of unique large-scale issues like the collapse of a global ice sheet, and the distributional are all equally important. And we certainly wouldn't want anyone to come away from this report thinking that it's appropriate to do a simple, traditional cost-benefit analysis comparing unmitigated impacts with costs of adaptation. That should be a part of it, but it's important to recognize that the numbers we present are not that. They're the numbers that are much closer to thinking about residual impacts. Those are the impacts that we have to deal with regardless of how effective we are with mitigation.
Patri.
Yeah, let me just add to that. I think quite apart from the economic costs, which can be and have been estimated through conventional means, we mustn't forget the fact that there's a large amount of impacts which you really cannot monetize easily. And in fact, in our special report on extreme events and disasters, we said specifically that loss estimates are lower bound estimates because many impacts such as loss of human lives, cultural heritage, and ecosystem services are difficult to value and monetize. And there's also a large undocumented economy in several parts of the world. Now that gets disrupted with the impacts of climate change, but it doesn't feature, I mean that loss doesn't feature anywhere in any of our formal systems that measure economic output. And let me also say that I expect this report will generate a large number of adaptation measures all over the world. And I think these will have to be estimated on a very location-specific basis. To carry out one particular action, let's say in North America, may cost something very different from what you have in sub-Saharan Africa. So my expectation is that in the next few years, you will get much more accurate costs, particularly of adaptation measures, on a localized and region-specific basis than we have today. But let me emphasize once again that these economic costs do not capture all the impacts of climate change, which to a large extent in several parts of the world go far beyond what economics can tell us.
Thank you, Patri. A reminder, if you're following this webcast or if you're following this press conference through the webcast, that you can send in questions to ipcc-questions@wmo.int. And in the meantime, if there are any other questions from in the room, we'd be happy to take them. At the back there, you raise your hand, sir.
I'm Martin Fritz, freelance from Germany. There is an old allegation against the this whole panel on climate change that it is alarmist, and there was a Dutch professor, Mr. Toll, who pulled out from the report because he said the report is going to be alarmist. And you were speaking about the struggling at night over the exact wording of the sentences and the report. So was this a struggle between alarmists and non-alarmists during these nights here in Yokohama? And what do you think about the allegation that you guys are just alarmists?
Chris.
Thanks for that question. You know, IPCC is a unique organization. The way I think about it is that when you get an IPCC report, you see the position of the scientific community. Our job is to represent the full diversity of scientific evidence and scientific views. And I can assure you that every IPCC author thinks the report would be a lot better if it put more emphasis on his or her own work. Absolutely, uncertainly, that's a very high confidence statement. The IPCC report is not about confirming or unconfirming the perspectives of any individual. It's about finding the position of the scientific community, and not just the 300 authors, the hundreds of authors who submit review comments, and the thousands of authors around the world who are producing the scientific literature that we're assessing. On every issue, there's a diversity of opinions, and our goal in the report is to accurately reflect those opinions. Now, on the issue of Professor Toll, a lead author, those of you who are watching the pictures from the proceedings here know that he was deeply involved in the proceedings, really helped us fine-tune the wording so that it was as accurate and consistent with the evidence coming from his chapter's analysis as possible. So he's been very much a part of this and very deeply embedded all the way through the fine-tuning that occurred over the last several days. I would like to take advantage of this question to say just a few words about what the goal is of the plenary approval process that's occurred over the last few days. The idea of the IPCC report is it provides a distillation of what's known and what's not known in the scientific community. It provides this clear picture of what we know and what we don't know, what the distribution of views is. As you've heard this morning, the scientists don't always capture the clearest and most eloquent, easiest to communicate terms. We use a lot of jargon. And our job in preparing this summary for policymakers is to provide language that really speaks to policymakers, that gets the issues right, that leaves minimal openings for misinterpretations and uncertainty, but still speaks to people who don't necessarily have abundant scientific technical knowledge or use the same jargon. So basically what we've tried to do over the last several days is figure out how to fine-tune the language, how to make things as clear and concise as possible, and make sure that we weren't saying things that could be confusing or open to misinterpretation. It's about getting the science right. It's not about altering or reframing the science. We come in with a science package and we come out, and those of you who have looked at the pre and post-approval session documents know that, we come out with the same science, but fine-tuned to emphasize the understandability, the clarity, and to minimize the risks of misunderstandings.
Well, I just want to add 2 sentences. I've been associated with the IPCC over the last 4 assessments. I was a lead author in working groups 2 and 3 in the second assessment report. Then I was vice chair of the IPCC during the third assessment report, and for the 4th and 5th, I've been chairman of this organization. And I can tell you it's a unique process by which we come to a scientific consensus, and I want to pay tribute to the scientists who have the rationality, who have the objectivity to take in a whole range of viewpoints and then come up with something that is scientifically valid and defensible. I do want to pay this tribute. Of course, everyone has, as Dr. Crisfield said, the unshakable faith that if they were responsible for doing the report, that they'd probably do it better than what comes out. But in the end, what we get is the best that is possible. And what makes it even stronger is the fact that the report is accepted, approved word by governments, because after all, the summary for policymakers has to be written in language that policymakers understand. And therefore, it's wonderful that the scientists are willing to listen to the governments and frame their findings in language that makes sense to the policymaker. So this, may I say, is the strength of the IPCC process. Thank you.
Thank you. Seth, please.
Seth Bornstein from AP again. Just for Chris and Dr. Pachauri, going back to food, and you showed about yields. I guess what I want to put that in context, don't we generally see with modern agriculture, the green revolution's been going on, an increase in yield every year? I think it's like 1% a year. So are you talking a net decrease in the future from where we are, or are you just talking about we're growing slower? Because those graphs look like less food. Are we still going to have more food? And does that difference between slightly less more food mean much?
This question illustrates one of the big challenges with doing attribution in human-dominated areas. And it also demonstrates, in many ways, the richness, but also the difficulty of the human condition, right? Lots of things are changing. We expect a world in 2050 with a global economy that's 2 to 4 times bigger than the current one. And does that mean, that if we spend 1 to 2% of GDP on mitigation, that we would just reach that wealth level in 2050 a year or 2 later? I mean, how do you think about all these issues with a moving baseline? And a lot of the motivation for this risk-based perspective is that you can think about providing protection for the less likely but higher consequence outcomes. What if we're not exactly right with those food projections and they come out with even bigger impacts than we've been talking about? Well, how should we think about climate policy, climate responses as building insurance, sort of the airbags on the Earth system? But specifically on the food question, the world has a remarkable record of increasing food availability, especially since the 1960s with the birth of the Green Revolution. And for several decades, yields of the world's major food crops increased almost 2% per year, a remarkable accomplishment. Those yield increases have slowed recently for many of the major crops, even with continued investments in management and technology and genetics and all the stuff that's made agriculture such a big success story. That rate of increase has dropped to something like more than 1% or around 1% per year for most of the crops. In fact, it's stabilized for a couple of them. And our finding is that part of that yield, the slowing of the rate of growth, is a reflection of the climate change impacts. And the expectation is that moving forward, this anchor pulling back on the opportunities for increasing yields with continued advancements in genetics and technology has the potential to get even bigger. So in the studies I showed, there were a combination that had different viewpoints on what the possibilities were for continued improvements going forward. At the same time, they were acknowledging the full range of processes that had the tendency to bring yields back. So we know nobody knows what's going to happen exactly in the future. And when we analyze these climate impacts, what we're really trying to figure out is against whatever the moving baselines are of developments in the economy and technology and research, how are the issues with climate change altering the trajectory? So you should think of those food results as saying there's the increasing prospects for a large negative impact on what the yields would have been in the absence of climate change. And as I showed, something like 25% of the studies are showing that by the end of the century, those impacts could be more than 50% of what yields would have been in the absence of climate change.
Let me just add to that. I think the point that Chris has made about increase in yields having slowed down, it's actually now becoming evident in some parts of the world that the so-called Green Revolution has probably reached close to a plateau. But the other point I'd like to make is that there's a large number of farmers who are totally dependent on rain-fed agriculture, are working on fragmenting areas of land. And therefore, for them, there's no such thing as the Green Revolution. And as it happens in terms of research and development, very little has been done to come up with methodologies by which, under those conditions, you can increase yields of agricultural crops. To give you an example, I come from India. There are about 800 million people who are living in rural areas, and a large percentage of the people engaged in agriculture, which is true of all of your rural India, are totally dependent on rain-fed agriculture. The Green Revolution has not touched them at all, and it's unlikely that given the social and economic conditions surrounding their activities, that they would ever be beneficiaries of the Green Revolution. And they're the ones who are going to be worst hit with the impacts of climate change. This is true of sub-Saharan Africa, this is true of several parts of Latin America, and so on. So I think we have to look at the totality of the picture, and therefore I think these are the sections of society which are really going to suffer the worst impacts of lack of security of food supply.
John?
Thank you. Well, actually, I was about to give the same example, Dr. Pachauri, so you make my answer easy. But in addition, I think we should not focus only on the average. You see, when you talk about climate change, it's also the extremes. When you talk about food productivity, yes, the food productivity has increased, but to some extent at the expense of vulnerability. In other words, much of this increased yield is with crops which are more sensitive to extremes. And if some extreme event affects one of the big producer countries of the planet, it translates not only into a local problem, but into a global problem, because it affects immediately the price worldwide. And it has been part of the previous food crisis, and we know all the ingredients are there for a new food crisis to come, because you just need a few extreme climate events affecting big producers on the planet, and the ingredients are there. The second point I wanted to make on that is that Even if you get away from rain-fed agriculture by using more irrigation, the key word is sustainability. Whatever we do, we have to look at it in a long-term perspective, because underground water is not always recharged at the rate which is necessary for sustainability. And you know of example in your country, Dr. Pachauri, where, and many other countries of the planet, where underground water is exploited at a rate which is not sustainable. And this is where the IPCC reporting process comes into the picture once again. Not only Working Group 1 and Working Group 2 is to say, okay, we make decisions now, can we make them in a sustainable fashion by looking at the benefit not only for the next 2 years, 5 years, but also looking at the at our children and grandchildren. Thank you.
Thank you. I have a question from outside the room from Stephanie Ogburn of ClimateWire. Could you give a more specific idea of some of the unsurmountable limits that societies may encounter if mitigation measures are not taken and we remain on the high emission scenario, and a time frame of when we might start to see some of those limits?
Sure. One of the things that's important for people to understand is that the scientific understanding of what a world with continued high emissions look like is far from complete. We certainly have techniques for evaluating some aspects, but those techniques are really pretty preliminary. You know, the world has been through some large climate changes in the past, and we have records from fossils and other kinds of samples. We have some modeling approaches, but we're talking about a world with foresee warming that looks very, very different from the current one. And so what are some of the things we can say? The projections for crop yields are that there's the possibility of very large impacts with big producing regions not being appropriate for continued investment in agriculture. And as Dr. Giraud says, you know, the issue with extremes is often not whether you get one or two extremes that produces a shock in the global price system. It's whether the extremes occur so frequently that it's not worth doing agriculture in an area. And I think that most of the analyses of large-scale shifts in where we might be growing crops have to do more with the frequency of conditions that push areas down below continued, let's say, sustainable or profitable operations. A second really big area of concern in these large-scale impacts is losses to biodiversity. One of the areas where the reporting in the AR5 is different than in the AR4 is the fraction of species at risk of extinction from climate change. The AR4 provided some very preliminary numbers indicating that something like 30% of species might be at risk of extinction from a modest amount of climate change. And the wording has shifted in the AR5 to indicate a very large fraction of species, we don't know what it is, but a very large fraction likely to be at risk of extinction from the combination of climate change interacting with all the other stressors that are impacting the Earth system, such that many scientists have argued we may already be either on the threshold or over the threshold of a sixth mass extinction in Earth's history. And then a final area that I want to highlight is really important is it's described in the reasons for concern as singular events. And the one that should be most on people's mind is commitment to loss of a major continental ice sheet like the Greenland ice sheet, which has enough mass of ice sitting above sea level that if that melts, we're talking about 7 meters approximately of global sea level rise. And there's some point in the future at which the climate system is essentially committed to complete loss of the Greenland ice sheet. We don't know if that occurs at 1.5 degrees above pre-industrial or 3 degrees above pre-industrial, but there's some point at which we'll pass a threshold for this, at least on the time scale of centuries to thousands of years, irreversible large-scale change in the Earth system with a commitment to meters of sea level rise.
Thank you. Another question from within the room, please. Gentleman in the second row again.
Thank you, Jonathan. Thank you, Jonathan. Again, Mizuguchi. Page 9 of SPM, said that in Europe, adaptation policy has been developed across all levels of government. My question is why only Europe were able to develop the adaptation policy across all levels of government. Is there any inter-regional scheme or policy framework? Thanks.
Yeah, that list you're reading from is really a list of examples of adaptation investments that are already beginning to occur. Think of it as a flowering of investments in adaptation in different locations. And one of the really great things about this report is that there's a big chapter on each of the world's regions. That list is really intended as a list of examples to show what kinds of things are occurring, kind of where we are in the world's thinking about the way to approach adaptation and the potential benefits of it. It's not intended to be comprehensive, and it's not intended to say that some of the things that are happening in one region really haven't in others. It's really to get people thinking about what's possible and what can be done.
Is there any experience and idea sharing scheme across Europe?
One of the really key themes that comes out in the analysis of adaptation is that opportunities for learning and information sharing are incredibly important. The adaptation experience tends to be spatially distributed and isolated and not very well evaluated. One of the things that I know the authors of our adaptation chapters found to be frustrating is that there are all these descriptions of things that are happening with adaptation, but it's really hard to do controlled scientific studies because you don't have one population that did the adaptation and then a control population that didn't do it. And so finding ways to learn from experience with adaptation that lets us do it better the next time is a real challenge, and there's a lot of creative thinking going on now about using sophisticated analytical approaches that we use in other parts of the Earth system to get a better understanding of what the counterfactual is, what would have happened in the absence of the adaptation, to enhance the learning and to enhance the information sharing.
Thank you. The webcast is going to end in just over 5 minutes, so we've got time for one, maybe two questions. Any? John Parker at the back there, please.
I just wondered how you dealt with the issue of the pause, the so-called temperature pause. I mean, did you say, that, well, the climate impacts might not be so great because we've seen, much smaller rise in temperatures in the past 15 years? Or did you say, well, by 2050, the pause might be over? I mean, how did you address that? How did you think about the issue of the pause?
Well, I think that the first thing that's important to recognize is that from the Earth system perspective, we haven't seen anything like a pause. What we've seen is that the Earth has continued to warm at a rapid rate, but over the last few years, for reasons that are only partially understood, more of that warming has been showing up in the ocean and a lower fraction has been showing up in the atmosphere. And even though the atmosphere has continued to warm, we've had more of the global warming showing up in the ocean. So the idea of a pause is not, it's just not correct. It's not what we're seeing in the data. What we're seeing in the data is continued rapid warming. And this idea of a range of possible futures is really fundamental to the risk framing approach that we've taken in Working Group 2. We have never in the IPCC said that we can predict with 100% certainty what the temperature is going to be in 2050. There's always been a range. When you look at impacts, there's an even broader range because we're looking at the dynamic interaction between rapidly changing human systems and rapidly changing natural systems. And so the way we think about the interaction between variability in the climate system, which is reflected in this increase in the fraction of the heating that's going into the oceans, is that that's part of the information you need in order to make smart decisions in the context of the framing for risk. In the big picture, the uncertainty about the responses of the physical system are small, very small, relative to the uncertainty in what's going to happen in the human systems with population growth, changes in the world economy, changes in where people live, and all those need to be fit together into this comprehensive picture of how to deal effectively with the future.
Thank you. Michelle.
Yeah, I would like to come back to this pause because I think it's very misleading. There is no pause. 13 out of the 14 warmest years ever recorded have occurred since the beginning of this century. What we call now a cold year, the coldest year since year 2001, which is actually 2011. The coldest year in this period is actually warmer than any year before 1998. So I have really difficulties to accept that we can talk about a pause. The thing which was expressed by Chris Phil, it is certainly true that the rate of increase, not the pause, the rate of increase is somewhat less than it was in the previous things, because indeed we have got a number of a significant fraction of the additional heat which is stored in the ocean. By the way, it's more than 90% which is stored in the ocean. Since 98, you have to keep in mind that whenever people talk about the pause, they always use 98 as the starting point. This is not science. This is selecting very specifically the starting point, which was the warmest, the strongest El Niño of the last century. This is not what scientists do. What WMO recommends is that when you look at trends, you have to look at longer period, not to isolate the starting point and the end point to draw the conclusion that you would like to see. So 98 was warmer because it was the strongest El Niño of the last century, and during an El Niño, we tend to have more heat transferred from the ocean into the atmosphere. Now, it happens that since 98, there were no strong El Niño. There were a number of La Niña, which also contributed to that. There was a number of interaction between the ocean and the atmosphere, which contributed to that. As Dr. Field said, there's a number of factors, and this is part of the natural variability, which itself is superimposed on the trend. So you have to look at the trend and the variability. And of course, if you look at short period, you can end up by drawing the wrong conclusions. So no, there is no pause, and the global Earth system, including the atmosphere, the ocean, and the land surface, continues to warm.
Thank you very much. We've just got a couple of minutes left. Does anybody on the podium want to say anything before we finish? Yeah, Chris.
I'd just like to close by saying that from the perspective of the hundreds of authors that contributed to this report and the thousands of scientists around the world whose work it's based on, what they really hope is that this work can be a start of a really sustained conversation about the way that climate change impacts future possibilities. There are lots of organizations that provide information about climate. I think those organizations are mostly bells. They're trying to ring as loud and as clear with some kind of a specific message. That's not what the IPCC is. The IPCC is a bell tower. It's trying to allow the world to climb up to a high point so that it can see as far and as clearly into the future, and to let people make smart decisions for their own purposes to use science to build a better world. Thanks very much.
Yeah, I'd just like to add to that by saying that one important conclusion that we can draw from the contents of this report is the fact that yes, we know much more about impacts, we know much more about vulnerability and how to adapt. We also have projections of the future on the basis of which we understand the limitations that there are for adaptation. And therefore, the one message that comes out very clearly is that the world has to adapt and the world has to mitigate. And the sooner we do that, the less the chances of some of the worst impacts of climate change being faced in different parts of the world. So therefore, I would say the Working Group 3 report, which comes out in a couple of weeks, will complete the picture and hopefully give us a very clear roadmap on how the world must adapt and mitigate in dealing with the challenge of climate change. Thank you.
Thank you very much, and that ends this Working Group 2 press conference. Thank you.